Now I explain the root locus Bode plot and Nyquist plot using MATLAB. Aim to study the effect of open loop poles and zeros on root locus contour. Second one, to estimate the effect of open loop gain on the transient response of closed loop system using root locus. Third one is comparative study of Bode plot, Nyquist plot and root locus with respect to stability. Consider the transfer function of open loop system g of s equal to 1 divided by s cube plus 5s squared plus 6x. That will I taken. So 1 divided, so numerator 1, denominator is x cube plus 5s squared plus 6x. So x cube 5s squared 6x, the constant is 0, that's why 0. This is the transfer function. Okay, for this we have to write the root locus and then effect of the poles in the root locus. Then that means we can adding the 0 in the root locus, this part of the program. This is the effect of loop gain k on the transient response. The last one is the Bode plot and Nyquist plot. These are the logic of this program only. So first you can open the editor window, type the program and then save the program as m.m file, and then you can go to file, open, you can open your programs. I saved in the desktop, that's why I already opened in the program in the editor window. Then you can go to debug, run the program. So the first one is nothing but the root locus. Okay, so for the given transfer function, what is our transfer function? 1 divided by s cube plus 5s squared 6x. Okay, so for this one and all we can draw the root locus, that is the Bode plot. So in the you can left click, you can automatically we can get the other graph only. So you see here and all, this is the poles. First pole and then what is the gain, what is the damping, overshoot. This is the second pole only, and then this is the what is the gain. Everything is in the Bode plot only. This is the Bode plot of the given transfer function. The second one is that is the effect of poles. See, this is the first pole. What is the pole? Minus 9. That is the 0.82. This is the pole. This is the next pole is the poles equal to minus 3. Third pole is the minus 1.8. This is the pole and this is the 0. So this is the effect of the pole on the root locus. We are getting this output. Then next one is the pole 0 effect. So this is the pole minus 2.9. This is the pole minus 2. This is the 0. So that is equal to 0 and all a circle, that is the 0 only. I can gain what is the pole, everything. This is the, that means again pole, damping, overshoot, everything under. So this is the effect of the pole and 0 on the root locus. Then next one is the effect of loop gain k on the transient response. So this is the transient response waveform. You see this is the steady state. After that only you can oscillation up and down only. This is the steady state one. This is the effect of loop gain on the transient response of the our given open loop transfer function. This is one of the output. The last output is nothing the Nyquist plot. For the given transfer function we draw the Nyquist plot only. So this is the real part is the x-axis, imaginary part is the y-axis. We can draw the diagram. This is the Nyquist plot only. So this is the graph, that means output of the given only. This is the root locus for the first output, that is the Bode plot. Second one is effect of the adding pole, that is the another output. Third one is that means effect of, that means adding zeros in the root locus. The next fourth one is the effect of loop gain on the transient response of the our open loop transfer function only. Next we are getting the Bode plot. Then this is the comparison Bode plot and Nyquist plot only.